In this episode, that is episode 2, we are talking about the role of intermediates. In the last episode, that is episode 1, we talked about the product analysis, how it is useful in determination of reaction mechanism. Now, in the episode 2, we'll go into the intermediate. Supposing when you know about intermediate, it would be easy for us to talk about how this reaction mechanism really happen. So what is intermediate? The species that are formed during the progress of reaction, provided having lesser energy, and if they are isolatable, and sometimes if it have a cliquet geometry, then we would say they are intermediate. Why do we study about the intermediate that are formed? Because that provides a very great deal of information talking about all the molecular events that are occurred in making the product. Therefore, when we are able to identify the prominent intermediates, and it is if it is isolatable, we can regard them as dots, and when we able to connect all these dots, we can get the picture, that is how the pathway or what the pathway by which the reactant becoming product. Now, to exemplify this statement, let's pay attention towards this reaction. This is an amide. Upon treatment with sodium hydroxybromide in presence of a base, that forms amine. But how do we ended up with this amine? What happened to the carbonyl system? So we need to understand the mechanism to explain how this carbonyl group came into disappear. So now we have two clues. That is, these are the two possible intermediate that are formed during the reaction. Number one, haloamide. Number two, isocyanate. When we able to understand how this came into existence, probably we can map out how this amide really turned into amine. Therefore, let's say this is the amine. In presence of a base, obviously the proton would have been outcaptured, leading into this kind of an anion. Now, followed by an electrophilic attack, we are ended up with the first intermediate, that is haloamide. In this case, the halo represents the bromine, and therefore now the the formation of intermediate explains how the amide would have been affected by the base and how it proves the reaction. Now that doesn't end the story. We need to understand how the isocyanate came into the picture. To that, let's say I'll do this way. Let's say one more time it is affected by the base capturing the proton, leading to the formation of this nitrogen type of species. Now after this, what might happen? There may be a conceited reaction might happen such that there may be a migration really happening across the carbonyl carbon to nitrogen, which is migrated, the R group get migrated, pushing off this bromide as a good leaving group, and once again leading into a formation of double bond, thereby the isocyanate might have formed. So this is the isocyanate that was being formed, right? So actually this is the complete mechanism, but then we need to account for how this amine really formed. Probably this isocyanate might reacted or may undergone hydrolysis, say water, and therefore by series of reactions, that is abstraction of proton and therefore hydroxyl group generated, act as a nucleophile. It further attacks the carbon and nucleophilic attack, leading into a this formation, right? Now what happens next? This carbon dioxide could have been departed if this nitrogen takes up the proton, right? So as we said, this has happened, leading into the formation of the product, leading into the formation of product, right? So that's how we ended with amine. That's why the formation of isocyanate as well as haloamide explains the mechanistic details such that one can predict the mechanism for this reaction. Now, while we understand the reaction mechanism with the help of intermediate, following points should be borne in mind. Number one, it's very crucial to identify the real intermediate. Or otherwise, we may be isolating or we may be suspecting some other species which is not really participating in driving the reaction. Therefore, we should crucially understand which is our intermediate. We should prove that it is beyond doubt that the following compound that was isolated is our intermediate. That should be very important fact. Number one. Number two, moreover, the isolated species might sometime may in equilibrium with something else. Therefore, we should not be get confused with the other one which is in equilibrium with the true intermediate. Therefore, we should directly go into the intermediate which are really formed by going into a direct logical reaction pathway. Okay, that are the two important factors to be taken care. But then we know that it is often the intermediate are not isolatable. Therefore, that's one problem. Why it is not isolatable? Maybe they are thermally or energetically labile. Number two, they may be somewhat in transient state to be get isolated. Therefore, in those circumstances, the spectroscopic techniques like IR spectroscopy, UV, or NMR often would do the job. Example, so here we have a ketone, and this ketone upon treatment with hydroxylamine, say for example NH2OH, would definitely lead into oxime. Okay, so what is the plausible mechanism that one can draw? Probably I would say that the NH2OH attacks this carbonyl group here, pushing this OH. So that can be drawn over here. How? R carbon R1 and here O with minus, let it here this NH2OH would have been really attacked. Okay, now what happens next? We can draw them very clearly for the sake of doing the appropriate mechanism. So I write it here, NH2OH definitely will bear a positive charge, isn't it? Why is it so? Because of this lone pair alone it part attacking the carbon, so obviously it bears a positive charge. So it grabs the proton, pushes this one back again. This will lead into a this type of group, R R dash, your OH, your NHOH. Now this is a very crucial step. Why? This is an isolatable intermediate. Now upon dissociation of this one, how it can dissociate? Any idea? Yeah. Well, I give you a couple of seconds for you to think. Those who do able to do that, that's well and fine. Others, this is very simple. The point is, this oxygen grabs this proton and departs as water molecule, and thus leading into this product. So this is the key intermediate. It is very difficult to isolate. Therefore, how do we prove this is the mechanistic pathway by which the product obtained? For instance, first we look into this carbonyl group. It is having IR stretching. In the IR spectroscopy, it has a stretching frequency around 1200 and 1721 centimeter inverse. Now in the course of this reaction, this band, diminishes, and at one point of time it completely disappeared, meaning there is no longer carbonyl group is present. In those circumstances, the OH was completely left. Meanwhile, looking into the product, a new band was emerged at 1281 centimeter inverse, which corresponds to the cyanide, and therefore this details of stretching frequency explains the disappearance of carbonyl group Thus, this carbonyl group, which one? This carbonyl group, you know, which happens to show the band at 1724 disappear, followed by the CN band. It has been appearing. So this is the peak in which you will be seeing that it has been appearing. So the disappearance of the carbonyl group and the appearance of CN takes place hand in hand. Okay, so that's how the intermediate formation, either by isolatable or by evidencing from the spectroscopic information, gives the complete picture of magnetic pathway. Thank you very much.